My name is Greg Endres. I work as an extension agronomist at the Carrington Research Extension Center. So to begin, I'd like to mention that about a year ago, we revised our pocket guide on soybean production, and it is available on the web, and you can use the keywords listed to find it on the web. Otherwise, the hard copy will be available or should be available by contacting extension offices or the Soybean Console office. So I'd like to begin by talking a bit about the data we've generated this past season on variety performance. So here it is, our new 2023 variety book is out. The hard copy have been printed, although I don't have one yet, but they'll be available very soon. Electronically, if you use the keywords that I list to search the web, you should be able to find this, readily find this document. And then also here's a website if you want to go directly to finding this publication as well as other variety performance data booklets. So within the soybean guide, we include, of course, some agronomic characteristics of NDSU varieties. We have a lot of companies that submitted entries for testing. It's a total, if my count was right, at 26 companies. And then we also list a website, so you can go there and look at more details that aren't evident in our booklet. We do have a lot of data tables, over 30, and includes research from 28 North Dakota sites this past season. And of course, broad categories where we show the data would include IDC, soybean cyst nematode tolerance, as well as, of course, herbicide resistant varieties that were tested, as well as conventional varieties. So this is a quick look at the companies that were cooperators that provided varieties for our testing program and the corresponding websites for them. This year, as in past years, we've included 3 pages actually of IDC scoring. And note that the trial mean was 3. And so we would encourage people that if they're concerned about IDC, choose those varieties, something less than 3. And I didn't count the number of varieties, probably over 200 that we had in the tests. And of course, here's pictures of relating to the scoring method that we have. So as a reference, here's a 3, and certainly something less than that would be very desirable. We have a lot of choices on herbicide resistant traits. We do have a publication as shown that will give an overview of traits available on all of our crops, but also including soybean. So this is the soybean table. Notice we do have a lot of herbicide traits out there. There will be more in the future, and the corresponding herbicides where there is resistance. So I bring this up because it's becoming more complicated to include all of these traits in our tables. And so our table titles, where we include herbicide resistant varieties, we just simply call them herbicide resistant. And in many of the tables, we do have a column as shown here that does include the traits. Now, when companies submit the entries for testing to us, we ask for the trait information, and that's what's shown here. But we would encourage you, though, if you're interested in a particular variety, be sure to contact the company, get the details from them, and ensure that the traits that are in a particular variety indeed are those traits that you want on your farm or in a particular field. So we have quite a bit of data, including pod height. At Carrington, we do take those scores, take some resources, some additional resources that generate the data, but we feel it is important because most instances people want to have the pod height above the soil line, certainly, so we can minimize losses and maximize the amount of yield that we generate during the season. So really an important factor to have pods above the ground is genetic selection or variety selection. There are other things that you might consider, some field management things. This is a publication that just recently we revised. In it is a table that shows some of the factors that we discuss: row spacing and planting rate. And notice that we did include lowest pod height. And so, as you would expect, going from 14 to 28 rows, 28-inch rows, that might help to increase the pod height, and increasing planting rates may help as well. So as you look at the numbers, yes, statistically there's difference. Note this is centimeters, not inches. And so the improvements in pod height are very subtle. So my experience is that some of these field management factors may contribute, but the contribution is pretty minor. A big thing is selecting a variety that inherently has higher pod height will be a good strategy. Ultimately, we want to avoid this. This is a picture of a field I took that was rolled, and then we experienced soil erosion. And so if there's opportunities to reduce the amount of ground rolling on our soybean fields, reduce soil erosion, that would be very good. And so variety selection certainly would be a component of that, of getting pod height to be higher. Okay, now we'll move into plant establishment. And so there's 4 questions I'd like to answer in my presentation relating to either planting decisions or plant nutrition. And they include, are there plant establishment strategies that can be tweaked or revised to increase yield potential? And most certainly, we're going to say yes. What are NDSU's current guidelines on the interaction of row spacing and plant populations? So I want to talk briefly about that. And then I also would like to go into plant nutrition a bit. This will be a warm-up for Dave's presentation that will immediately follow. But a couple of questions that I want to address would be, is there an advantage to the strategy of prior year application of phosphorus fertilizer? And then another one is, what are universities, land-grant use universities, finding as they test some biological plant nutrition seed treatments? So if you've heard me talk about soybean in the past, I've very likely displayed this table. This table is revised on an ongoing basis. And the reason I'm showing this is that to me, this is a very concise way to cover many different plant establishment factors. And so I'm going to talk about it very briefly. These are 10 factors that we've researched. And what we're after is to move from option B to option A because of the yield advantage with A in percentage, and it's based on the many trials that NDSU conducts. And so as an example, we have planting rate. And so, and I want to mention too that moving from option B to option A, we want you to make that step if possible, but then that's not the final step. There's some tweaking that can go on. And it's much like Dave Franson's N calculator. You go through and enter the appropriate numbers relating to the soil, and then ultimately it gives you a recommendation. But then there's opportunity to adjust that N rate, adding 30 pounds extra, or maybe deducting 30 pounds because of your knowledge of a field. And the same here. This is where we want you to move to, but then it's up to you to make those final adjustments based on your experience on past field history, on the variety grown, and soil characteristics, etc. I'd also like to point out a variety maturity group. Notice that our data is indicating that just adding even 1/10 of a maturity group to a variety of interest can help increase yield potential. There's always exceptions to this. Sometimes there's early maturing varieties that are very productive in yield. But in general, if we can expand our maturity groups, it gives us opportunity for higher yield potential. In North Dakota, our growing season is short, and certainly we don't want a variety, a soybean variety, to be done and still have significant growing season less. We want to avoid that. So most people, farmers certainly are rather aggressive on choosing full season maturity, and there's risks if we push it too hard, but just want to keep this in mind that trying to match the maturity group with the season, match as closely as we can, certainly can provide yield benefits. And then also I want to mention a couple of things relating to plant nutrition. One factor is seed inoculation with soybean history. Notice its grade. We say yes, but there's certainly debate about that. But based on 16 trials, the average is that we do see a modest yield increase with continuing to inoculate the soybean seed. So again, it's grade, it's not black and white, but something that I wanted to point out to you. And then another is pea fertilizer application. Over time, we've always suggested that broadcast application of P is recommended based on data from other states, but keep in mind there are some economic considerations with that. In work that we did where we compared band application of P away from the seed compared to the broadcast, we saw a very minimal yield increase based on the average of 7 trials. So it's up to you. We'll continue to recommend broadcast, but only if it works for you economically. So that would be the comments that we have on this table. On the next question to be answered, what is NDSU's guidelines on the interaction of row spacing and plant population? NDSU has devoted a vast amount of resources on trials looking at row spacing and planting rates and resulting plant populations. We've been doing this work for nearly 3 decades, and we felt it was time to try to compile this information and maybe have more precise recommendations with the 2 factors. So we did this with the publication that I just displayed. And so a very quick summary on what we found, and this is by regions. And what's interesting is in the East or in the West, narrow rows always won. And in the East, we found the planting rates of about 170,000 pure lye seeds per acre provided optimum yield. What was also interesting is with wide rows, the planting rates actually had to be higher in order to optimize yield, which might be contrary to thought from by quite a few people. In Western North Dakota, narrow rows won again. Note the trials included 7 to 10 inches, and the planting rates were less than the East, averaging about 150,000 pure lye seeds per acre, providing the optimum yield. But keep in mind, this is for optimizing yield, but economic yield needs to also be considered. And very simply, if we are increasing planting rates, we would hope that the cost of the seed is less compared to the increased yield that would be generated and the revenue with that. So if we apply this, ultimately we want to see what the plant population is early in the season. If we use our guidelines in the East of narrow rows, 170,000 pure lye seeds per acre, and then certainly even if it's pure lye seed, they don't all result in established plant. And so 10% field loss is relatively common. And so with this information, if we can end with about 150,000 plants per acre, that should optimize yield. Keep in mind, this can be tweaked then to fit your particular field. In the West, using narrow rows, that planting rate I mentioned earlier, at 10% field loss, if we end up early season with 135,000 plants per acre, that should be very good. So what it boils down to is that we need to go out and take those plant counts. We can start with these numbers, but the ending point would be up to you based on the factors we talked about previously, about soil characteristics, variety selection, past field history, etc. Okay, moving on a bit on plant nutrition. This is information from AgVice that came out very recently showing soil samples with soil tests P levels below 15 parts per million. And so note in North Dakota, we're at pretty high percentages, certainly higher than our sister state. And so there's certainly need for phosphorus fertilizer application with many crops. So we've explored the strategy of prior year P fertilizer application. And some background information. First is that our seed yield response is expected with phosphorus fertilizer application when we have low or very low testing soils. And this is based on the Olsen test at less than 8 parts per million. Also, another factor to consider with the strategy is soil pH. If it's greater than 8, we would suggest annual fertilizer application. If it's 7.5 or less, then the application timing may not be quite as important. And then how about in between? We're really not sure, and that's maybe part of the reason why we conducted this study. And then one other consideration with this strategy is that there are some benefits. It gives us more flexibility on P fertilizer purchase. Supplies sometimes can be questioned, especially a couple of years ago. We were really concerned about even getting fertilizer and what the cost would be. So this spreads things out over 2 years instead of 1. And then we may have savings on application costs, both the fertilizer application across the field, and then with conventional till, we would save a trip of incorporating the P fertilizer. So with all that said, at Carrington, we conducted the work for 3 years, and this is a look at the yield response with the application strategy over 3 years. Note that on where the trials were conducted, the soil levels were either very low or low, and note the pH was 7.7 to 8. And then the P fertilizer that we applied was at NDSU's recommended rates for each crop. So it was a 2-year process to generate the 1 year's worth of data. And so note that we did get a response with the P fertilizer application compared to the untreated check. The treatments certainly were the first year of the 2-year trial. We planted corn and applied phosphorus for the corn. And then the next year, with soybean following, we applied the appropriate amount of phosphorus. We compared that treatment to upfront loading of phosphorus. We applied phosphorus required the first year for the corn, plus extra phosphorus for the following year's soybean. So ultimately, statistically, we saw no difference in the yield with the first year application of P for both crops versus sequential. So based on the parameters of this trial, keep in mind the soil P test and the pH, we see the strategy working adequately versus the conventional each year application. And we'll probably be conducting more research to look at this further. Okay, and the last factor is looking at some biological seed treatments. This is a publication that we just recently revised. We looked at planting rates, row spacing, but also some especially foliar inputs. And ultimately, we found in this early work that we didn't need the foliar inputs to realize the highest net revenue. What were those foliar inputs? Well, I listed those down below: a micronutrient mix, growth promoter, and then a plant health fungicide. And if you want to know specifically what they are, you're going to have to read the publication. So there's a lot of interest in biologicals these days, and NDSU was able to join a national effort to study some plant nutrition seed treatment products. And the work in North Dakota was led by Hans Kandel, our past extension agronomist. So there's a lot of claims in the market on biological seed treatment. Some of the things that are addressed are listed. This national study took place in 2022 and was continued last year. Last year, you notice 21 states, 55 locations. This is small plot work with a very adequate amount of reps. Here's what was tested this past season. And so note that in treatment 10, it was untreated control. It did include fungicide, insecticide, seed treatment, and I assume all of these treatments included these. And then also note treatment 3 is where they used a standard rhizobia bacteria treatment as a treated check. And then the balance of these, if they're in blue, they're non-rhizobial bacteria. And then the the brown, the scomas, is actually a arbuscular mycorrhizal fungi. So what do we find? Well, this is 22 data, not all the same treatments as what I just displayed. And note the black is untreated check and the green is the standard rhizobia seed treatment. And these are listed numerically on yield response. And ultimately, we did statistically no response or no difference in yield amongst all of the treatments. How about in 23? Story was the same. There's a numerical rating here, but statistically, there is no difference in yield response amongst the treatments that were tested. And so we've done some fairly extensive testing across the U.S. with selected products, and we're having a difficult time seeing a clear yield response with these. But stay tuned, there'll be more work done. So I better close, and I try to answer these 4 questions. If there's others, and if there's a little time available, I'll try to address those.